Lesson 8.13 is even and odd functions. Even function and odd actually mean it has some kind of symmetry, but they're symmetrical about different things. What an even function is symmetrical about the y-axis. So see how if I were to fold this half over the y-axis, they would completely match up. And so it has to go through the origin here and then be symmetrical with this vertical line. Okay, versus odd, think about odd, starts with O. It's going to have symmetry about the origin, which actually means it's been reflected twice. So it's like it's been reflected over the y and then reflected over the x. Or it's got this diagonal symmetry. See how it's diagonal here? Where if I were to draw a line like that, that's not very good, but see how this is equidistant, this is equidistant. Kind of helps a little bit. But anyway, so it makes this diagonal symmetry. What happens mathematically is that if I have my function and I plug in a negative x, I still get out a positive y or the same y. So let's take this one for example. This is actually the graph of y equals x squared. Or I could say f of x equals x squared. When x is, let's say 2, then I know f of 2, or the y value at 2, or 2 squared, is 4. If I plug in x is negative 2, f at negative 2 or y at negative 2 is still 4 because I'm squaring a negative. So see how they equal that same thing? Saying I plug in a negative of x, I still get the same y, or a positive y. Versus an odd function, this is actually the parent of f of x equals x cubed. And so when I plug in a negative x value, it's actually going to make a negative of the y. And so if I have x is, let's just pick 2 again. F of 2, or the y at 2, is saying 2 cubed, which you can see on the graph is going to be 8. If I plug in x is negative 2, negative 2 cubed is actually negative 8. So it's the complete opposite of what it was. So that's what I'm trying to get at, is even functions, whether it's a positive x or a negative x, you get the same y value, making them symmetrical. If it's an odd function, you plug in the opposite x, and if you get an opposite y, then that's why it puts it down here in quadrant 3, making it symmetrical over the origin. Okay, so let's try some. Determine whether each function is even, odd, or neither. So I'm going to always plug in a negative x, not a number, but a negative x. This would be 8 times negative x to the 6th minus negative x squared minus 2 times negative x to the 4th. This is very abstract. So now I want you to think about x being a number. If I have a negative number raised to the 6th power, so I'm taking a negative times itself 6 times, that becomes a positive. So this would be positive 8x to the 6th. If I have a negative number squared, that's still going to become positive, and I'll have minus in front, so minus x squared. Negative x to the 4th would be a positive x to the 4th times a negative 2 would be negative 2x to the 4th. Compare the beginning problem to the end. It either has to stay completely the same or be completely the opposite. And it looks completely the same, so that would mean it's an even function. Meaning whether I put in a positive x or a negative x, I get out the same result. All right, number 2, plug in a negative x. So I'd have a negative number to the 7th minus 8 times negative x to the 5th plus a negative x, or minus x. A negative number to the 7th power, a negative times itself 7 times is a negative. A negative times itself 5 times is a negative. So think about now I got to take negative 8 times negative x to the 5th, and then negative x is obviously negative x. So that would be negative x to the 7th. Negative 8 times negative x to the 5th would be positive 8x to the 5th minus x. Compare. See how instead of x to the 7th, now it's negative? Instead of negative it's positive, instead of positive, it's negative. Everything's a complete opposite, so it's odd, meaning that's going to put me from quadrant 1 to now the total opposite, which is quadrant 3. And then the last one, you can probably guess what it's going to be. Got -9 times a negative number to the 5th plus 6 plus a negative number squared. So a negative number to the 5th is a negative, times this negative is a positive 9x to the 5th. 6 is going to stay. A negative squared is now a positive. So compare. The 9s are opposite, but the 6 stay the same and the x squared stay the same. You can't have some change and some stay the same, so this isn't either. Okay, and then real quickly, there's another one page that goes with these that's multiple choice. Determine whether the degree of the function is even or odd and whether the function itself is even or odd. So the degree is saying the exponent. So we've got this from in behavior. Okay, so if they both go down, same direction, that means it's an even degree. So we're going to take off the bottom two. It's an even degree. Is this an even function? Does it have symmetry over the y-axis? Yes, so we would say it is an even function. Number 5, one end is up, one end is down. That means it's an odd function, or odd degree, I should say. And then does it have symmetry about the origin? Is it this diagonal symmetry where it's reflected? Like if I were to fold and then fold, would it be on top of itself? Yes. And then number 6, both ends are going the same direction, so that means it's an even degree. Is it an even function? Does it have symmetry over the y? Not quite. This would have to be moved over one so that this would put it right in the middle. So this is, it's not an even function. Number 7, ends are going in opposite directions, so that makes it an odd degree. And it's not in the center either. This would have to be moved up here. It's got to go through the origin to be odd, an odd function, so it is not. So again, degree is based on the end behavior, so you might want to watch or write that. So are both ends going the same direction or opposite, and then check the symmetry for whether it's an even or odd function.